So we want to name this acid here. Maybe you recognize this right off. It's a very common acid. Hydrochloric acid. And it's because it's chloride. It ends in IDE, so hydro. Nitric acid, what's the formula for the acid? Nitric. So ic means the anion is, the anion must be, if it's nitric, the anion's got to be nitrate or nitrite or nitride. No. If it's ic acid, then take a look at the chart. If it's ic acid, then the anion is an 8. And so it's nitrate. What's the formula for nitrate? NO3 minus. And then how many H pluses will we need to balance the charge? Just one. And so nitric acid is HNO3. What's the anion in the next acid here? Looks like the anion is PO4 with what charge? It's going to be PO4 with a charge of negative 3. That's right. And what do we call this? PO4 negative 3? Phosphoric. Yeah, this is phosphate, which is going to form phosphoric acid. All right, do the next one here. Next one is hydrosulfuric acid. What is the formula for hydrosulfuric acid? Or somebody tell me what the anion is. Is the anion sulfate? No, it's not sulfate, because if I just have ic acid, then it would be 8. But I have hydroic. Hydroic is for ides. And so the anion is going to be sulfide. What's the sulfide's formula? SO4, 2 negative. This is sulfide. Somebody just asked me what the D represents versus a T. What does a T represent? What does a D represent? Oxygen. Which one has the oxygen? The D or the T? The T, because we have 8 and ite. The difference between 8 and ite is the number of oxygen. So what is a D? Is D more oxygens than an 8 or less oxygens than an ite? Less? And so how does it go? SO4 2 minus is what we call what do we call that? Sulfide. And then what would SO5 2 minus be called? Persulfide? Oh no, it's got to be sulfade. Sulfade. This must be sulfade. Is that right? No. That's because when it's a D, chances are there's no oxygen present. When it's a D, we call it monatomic. What does monatomic mean? One atom. So we got to get rid. Which atom should we get rid of? The sulfur or the oxygen? Get rid of the oxygen. So sulfide is just S with what charge? Two minus. It's S with 2 minus. And so how many hydrogens do we need to balance out that charge? 2. And so the formula for hydrosulfuric acid is H2S. H2S has multiple names though. H2S is a rotten egg odor gas. there are a lot of bacteria that metabolize sulfides to form, or sulfates, excuse me, sulfates and sulfites to form sulfide. And so H2S is called hydrosulfuric acid. Typically when it's hydrosulfuric acid, it's dissolved in water. Do you know what we write here when it's dissolved in water? Not much is dissolved in water, but a little bit does. We call it AQ, AQ standing for aqueous. We normally don't call it the acid name when it's in its normal state. In its normal state, H2S is a gas. So it's H2S, it's the rotten egg gas. Very toxic. It's called hydrogen sulfide. And so at oil refineries, you got to watch out for hydrogen sulfide leaks. One oil refinery in Ventura, or it wasn't an oil refinery, it was a oil well in Ventura. Somebody died. It was like maybe 10 years ago from hydrogen sulfide exposure. So it's nasty. What's this one called? Here. What's the anion? Is that nitrate? Nitrite? Nitrite. That's nitrite. Therefore, its acid would be called nitrous acid. Nitrous acid goes here. What's hydroselenic acid? Well, it's got to be selenium. It's got to be monatomic selenium. So let's take a look at the periodic table. Where does selenium reside? Here it is. It's element number 34. Selenium, Se. Where is it by? It's right below sulfur. And so, what would the formula for the ion be? You're right. You're going to need two H's to balance out the negative 2 charge of the selenium. So it's just H2S, E. Remember, selenium and sulfur are in the same family, so we have similar names here. This would be hydrosulfuric acid. This would be hydroselenic acid. This would be hydrogen sulfide gas. This would be hydrogen selenide gas. So there's parallel in that. Hydrogen selenide smells bad. They say that the sulfur-containing and selenium-containing compounds are the worst-smelling compounds on the periodic table. This one we already did, HClO4. What was the name of that one? Hydrochloric is not it. Hydrochloric is just HCl, perchloric acid. We already talked about that. Let me skip it if we can. The next one, hydroiodic acid. Hydroiodic acid is what? Well, if you know what hydrochloric acid is, then hydroiodic acid is easy. What is hydrochloric acid? HI. Therefore, hydroiodic acid, hydrochloric is HCl. Therefore, hydroiodic acid is HI. Hi, exactly. HClO2. Hydrogen chloride, yeah, but typically it doesn't form a gas, so we don't usually call it by its ionic name. You know, well, these are tricky here because here in acid, the acid name is hydrosulfuric acid. The ionic name is hydrogen sulfide. The molecular name is dihydrogen monosulfide or dihydrogen sulfide. And so the nomenclature system gets a little bit tricky. So sometimes, and so these we don't normally call by their ionic name. The ionic compound name would be the cation name, hydrogen, the anion name. What was the anion name on this again? Chloride. And so we'll name this as the acid. So what is the acid name on this? If it's chlorite, then the acid name would be chlorous acid. This is chlorous acid here. Selenic acid. Selenic acid must have the anion, what? Selenide? The selenic acid? No, it's missing the hydro. Hydroselenic acid is selenide. Selenic acid is
HSEO.
SEO. No, tell me the name of it. Selenide, selenate, perselenate, hyposelenite. It is selenate. Selenate you should be able to get from the periodic table. That's not hard. Think. What is selenate? SEO. Do you have sulfate memorized? If you have sulfate memorized, then selenide's easy because it's the same thing.
SEO4.
SEO4. Charge? SEO4. 2. Negative or positive? And so how many H's do we need? 2. H2, SEO4. Let's go to the last one. What's the last one here? Is that perbromate? Well, actually, we always ask ourselves, is it bromate? Because we should know what bromate is. What is bromate? B-R-O. No. B-R-O. Yeah, you only have two choices, 3 or 4. Bromate is going to be. You're going to say 4 and you say 3? Well, let's look at the periodic table. If we take a look at the periodic table, what is bromate? Is bromate in the 3 oxygen or the 4 oxygen group? So we look here, bromate's here. Is it in the 3 oxygen group or the 4 oxygen group? 3. It's in the 3 oxygen group. 3 oxygen. How do I know it's 3 oxygens? Because it's anchored by what? Sounds, you know, people get it mixed up all the time. They mix up bromate with what? Not bromide. That's a more difficult mix-up. Actually, this is an easy mix-up. Bromate gets mixed up with borate. Bromate and borate get mixed up all the time. But you should know what borate is. What is borate? No. VO3 charge. VO3, 3 minus is it. How did you figure that out? How did you figure that out? Do you know this guy, Bruce Lipton? Epigenetics? I'm not that familiar with this field, so I was just listening to one of his talks. This guy's kind of interesting.
Where am I struggling? Because wherever you're struggling, inevitably it's a program in your subconscious that's going to support that destination.
Well, this guy's saying you're programmed from age 0 to 7. Have you heard that?
You can learn in any number of ways. Read self-help book, go to lecture. Listen to this program. And conscious mind is going to get some awareness. And I go, yeah, but the subconscious mind doesn't learn that way, right? It doesn't. The subconscious mind learns in two fundamental ways naturally. Hypnosis, which is the first 7 years. And after age 7, how do you put new programs in? Repetition. Practice. You want to drive a car, you didn't want to learn how by just getting in the seat and being it. You had to practice driving a car. You want to learn the alphabet. How many times did you go from A to Z? Try to go to A to Z before you can complete it. And once you completed it, you didn't have to go back and do it again. So 2 phases. You want to train the subconscious mind. Hypnosis. Repetition. I like the last one because there's a new phrase that's bandied about called fake it till you make it. Meaning, if you're not a happy person, I say you want to be a happy person, then repeat all the time. I'm happy. I'm happy. You say, well, you don't look happy, right? You say, who am I talking to? By repetition, I'm talking to subconscious. If subconscious gets, I am happy, and 95% of your life comes from that subconscious, there will be a point once the subconscious got, I am happy, you're going to have to say it again. Okay? It'll be automatic.
And that's why we see people do affirmations and gratitude journals and stuff, because if you do that daily,
It's repetitive, and that's it. That's the secret part. But putting a sticky note on the refrigerator is more like a suggestion, but it's not a repetition. So it doesn't work very well. But you have to, repetition is a habit. It's making habit. So you got to do something religiously in the sense of repeating it, repeating it, repeating it. Really important.
This guy did pioneering research on stem cells and genetic expression. And he was talking about how much the environment, like if you take stem cells, all stem cells are coded the same genetically, but depending on the medium they're in, some stem cells grow into muscle, some stem cells grow into bone, some stem cells grow into fat. And so he's just talking about this kind of programming that's done. But when he started talking about getting it in your subconscious, that's where we want this. We want this information in our subconscious. How do we get it in our subconscious? Repetition. How do you get repetition? You just read your notes over and over again, and that's how you're going to master this stuff. You'll totally master this if you just do repetition. That's it. Although you only had 1 day for this, so I don't expect you to get it right off. But you can listen to more of his ideas about getting learning in the subconscious, into the subconscious. How did I get, because I asked you to memorize 2 ions. What ions did I ask you to memorize in the periodic pattern? What were the 2 ions I asked you to memorize? And Kyle, how did you figure it out? Was it a lucky guess? Or was it your subconscious? Or what was it? If it's repetition, it's like motor memory. Yeah, for me it's totally easy. VO3, 3. BO3 3 because it's in group. The way I remember it is this, and this is why I asked you to memorize it. The way I memorized it initially is it's so simple. Or you get a can of Coke, or get some eye drops. If you get some eye drops, you'll see this ion in eye drops or a Coke. But it's easy. Oh, did I just shut it? Shoot. I just shut the window. Let's sign in again. Actually, I don't want to sign in there. I want to do the periodic table. So, I don't have enough time to do too much repetition. Some people say you got to repeat things 5 times. Well, I'd like to repeat things 5 times, but there's no way near enough time to repeat it 5 times. So you guys are going to have to do the repetition yourself. Because I'm just going to, some stuff I'm just going to say it once, and that's it. I'm not going to go back to it. The people who remember it will have a huge advantage, because here, boron, what group is it? 13 or 3A. And that's how I remember it's 3. How do I remember it's 3 oxygens? Because boron's in group 3. 3A. Therefore it has 3 oxygens and a charge of 3 minus. And that means all these in this series have 3 oxygens. And what was the other ion I asked you to memorize? That's borate. I asked you to memorize borate. Did I do this, or is it a cake? No, I didn't do this? Oh, maybe that's why. Maybe that's why. It shouldn't be that hard. I expect more people to have known this. We can save ourselves a lot of memorization. Some 8s we have to memorize. The 8s that we just have to plain outright memorize are things like chromate. Here you just repetition, write it over and over again, like 50, 100 times is usually the way I remember this. Dichromate. There are tricks to remembering dichromate. It's like 2 chromates, but minus 1 oxygen. And that minus 1 oxygen makes total sense if you know the structure. Because of an oxygen-oxygen bonds, you might have seen oxygen-oxygen bonds before, but are oxygen-oxygen bonds really stable? No, because when you have an oxygen-oxygen bond, it forms what type of link? It forms what's called a peroxide link. Peroxides are not that stable. And so when we join 2 chromates together, we lose 1 oxygen, otherwise we have an oxygen-oxygen peroxide type link. And then we have permanganate, which is different than the PERs that we covered earlier. This is permanganate, MnO4 minus, and then we have something called oxalate, which is C2O4, 2 minus. But do we want to have to memorize all these? Do we want to have to do flashcards for all these? Or write each one over and over? No. If we had some kind of pattern, we could save ourselves a lot of memorization. And it turns out there is a simple pattern in the periodic table. In the periodic table, if we start with boron and BO3, 3 minus, because boron is in group 3A or group 13. And so this periodic table is not the best for that. Let's look at a different periodic table like this. If we look at this periodic table, what group is boron in? 3A. And so it's easy to remember. It's 3,3, right? And this is called borate. And that means all the species in this series have how many oxygens? Well, all the species have 3, because the next one over is CO3. It's carbon. And this is called carbonate. And so I don't have to memorize carbonate if I know borate. Because if I know borate, then carbonate has the same number of oxygens, except the charge. The funny thing about the charge, and this is where you need the pattern, is the charge drops to 2 minus. And the next to carbon is nitrogen. What is nitrate? How many oxygens does nitrate have? 3. Except the charge is not 2 minus, it's not 3 minus, it's 1. And so this is nitrate. And then oxygen we skip. And then we go to fluorate, what is fluorate? Okay, take a guess what fluorate is. Fluorate is going to have FO3, 1 minus. Chlorate, ClO3, 1 minus. And so it stays the same. If we go chlorate to bromate, bromate is BrO3 minus, it's bromate, and iodate is the last one. Iodate is IO3 minus. And so if we know the eights, then we can figure out the ites, the per-eights, and the hypoites. And so for example, if this is the 8, then the ite is what? The ite is 1 less oxygen. And so if this is the 8, then chlorite will be ClO2, and the charge is the same. We don't change the charge. And so if we know the 8, then we know the ite. Then we also know the per-8. Not everything forms a per-8. Should chlorate form a per-8? Well, look, what is the charge on chlorine here? The charge on oxygen is -2, so we have 3 of those, is -6. -6 plus what gives us -1? +5. Is +5 maxed out for chlorine? What is maxed out for chlorine? +7. So +5 is okay. That means we could add another oxygen on there. If we add another oxygen on there, then we're going to get ClO4. Charge doesn't change. This is called perchlorate. What's the charge on chlorine here? What's the charge on chlorine here? Well, oxygen is -2. We got 4 of those, -8. -8 plus what gives us -1? +7. Are we maxed out there? Would you expect a per-8 to form? Or a hyper-8? You know, have you ever heard of hyper-8? No, there's no per-8 or hyper-8 in this case. We've got to stop here. However, we could go down, you know, because if we go down, chlorite's this, we could lose another oxygen. If we lose another oxygen, then we'll have ClO minus, which would be called? Not chlorus. If we go from chlorite, then we would go to hypo. Hypo means less, hypochlorite. Hyper means more, hypo means less. And so this hypochlorite. Not everything forms hypo and pers. It depends on where it is in that range, right? How easy it is to get along. These are patterns that we see. And eventually these patterns we want, you know, we want to understand better. And so I asked you to memorize, or I didn't ask you, I forgot to ask, do this, but borate is 1. The other one you have to use as an anchor is 4. For group 4, we're going to drop 1 down to silicon. And the other one you need to remember is this one, SiO, well it's group 4, so it's 4,4. SiO4, 4 minus. This is called, if you're a geologist, this is easy. If you're a geologist, you deal with silicates all the time. However, most of you aren't geologists, so you probably rarely deal with silicates, you know. And the silicates are very common: granite, silicate minerals, etc. And so, if we know this, then that means the inner block here. These are all with 4 oxygens, and then the chart. So, for example, what comes under silicon is germanium. What do you think germanate is? Now this is tricky because we need more data. We can't really see the pattern just yet. Germanate is GeO4, 4 minus. Well, next to silicon is phosphorus. What do you think phosphate is? Yeah, it's going to be PO4, 3 minus. And below phosphorus is arsenic. What do you think arsenate is? ASO4, 3 minus. There's a very interesting story about this. Phosphates are very important in biology. Have you heard of ATP and ADP? ATP and ADP are like the energy molecules for us. However, for extraterrestrial life, they might not have that much phosphorus. And so there was a NASA scientist who went to, Owens Lake near Yosemite. Owens Lake doesn't have any fish. It has very high levels of arsenic, but there are bacteria living in there. And so this one scientist came up with a hypothesis that maybe the bacteria don't metabolize phosphate. Maybe the bacteria metabolize arsenate. Arsenate, because there's so much arsenic in there. And so that scientist ended up publishing a paper in Nature with some data showing that potentially those bacteria are arsenic-based rather than phosphorus-based life forms, which would be very interesting for other planets. Right? However, science is how does science check itself? Science checks itself by peer review, and that paper was harshly criticized. You would think, because hey, phosphorus and arsenic in the same family makes sense, doesn't it? Makes sense. Unfortunately, this is Mona Lake here. Unfortunately, it was really exciting, but unfortunately, it was debunked. The arsenic-based life forms that were discovered in Owens Lake turned out to be contaminated externally. So, but they did find some kind of alien organism. Maybe. Alien being not a typical one. So this was 2010. It was hailed as alien life form living on Earth in this bacteria. And so, we use these patterns to try to understand, of course, properties, structure, and other stuff. And we also use these patterns to ease the memorization load. Because rather than making a whole bunch of flashcards for these, we just memorize 2, and then we can generate the rest. It'll save us a lot of memorization. All right, well, we're out of time, so we'll stop here. All right, if you can check Piazza and see.